Today we're going to start with section 4.3, a very important section. You can see that the actual number crunching is going to pick up a little bit here. We're going to go over measures of dispersion. And we've already talked about what a deviation is, like how a number varies about another number. But we didn't really go into any detail. And so that's going to be a big part of what we do today. One of the ways that we can obtain information from a set of data is to look at the deviations from the mean. Alright, and so you know what the mean of a set of data is. And if we looked at deviations away from the mean, what we're really looking at is how data items vary or deviate around the mean. Okay? And so that's going to be the main topic today. Your book goes through one term that you may or may not ever see again, called the mean absolute deviation. So I'm not saying this isn't an important term, but this is definitely not as important as some of the stuff that we're going to go over in just a minute. But there's a formula given for the mean absolute deviation. For a sample, and the book, the way it abbreviates mean absolute deviation is MAD. So kind of funny. But the MAD, it says the mean absolute deviation is equal to the summation of x sub I minus x bar all over n. Alright, and this formula is kind of similar to what we're going to go over in just a second. So it is related to the variance or standard deviation, but it's just a little bit different. You have an absolute value there. Alright, so the big topic of today is variance and standard deviation. Alright, they are the most common measures of variability. And it really depends on whether we're looking at a population or a sample. They are calculated slightly differently, or slightly different. The first thing that we're going to go over, the first term, the first important topic here is the variance. Alright, and so the variance of a set of data, if it's a population, the way that you write the symbol that's used for variance is a lowercase sigma squared. Alright, and this is for a population. So population variance is sigma squared, and that's equal to the sum of x sub I minus mu squared all over capital N. Alright, so x sub I is just every x value. So you have to make this calculation for every x value. X minus, and then what is mu? Remember, that's the population mean. And then capital N, that's going to be the number of items in the population. Alright, the sample variance is very similar. Alright, and the variable that we use for sample variance is a lowercase s squared. That's the sum of the difference in each data item minus x bar. What is x bar? The sample mean squared divided by n minus 1. Alright, so what we're actually doing is we're taking and we have to first figure out a mean. Then we're going to take each data item and we're going to calculate a deviation. This right here, this is a deviation. This is the data item, the x sub I. The x bar or the mu, that's the mean. And so you're going to take that difference there and square it. Alright, so that means that you can't get anything negative in the numerator, right? And then you're going to divide by n minus 1 once you have completely finished working out the numerator. And so it's best to make some type of table, even if it's a small table, whenever we're trying to find variance or standard deviation. And we're going over standard deviation right now. So let's go over the example from the book first, from your ebook. And then we'll pull up a few more examples and work on those. So here is the example from your book. Alright, so given the following times in minutes of 6 persons running a 1,000-meter course, compute the sample variance. Alright, so this is sample variance, so that's the second formula we went over. We have to figure out a couple of things. We have to figure out the mean of the sample, right? So we need to figure out x bar. So x bar equals 4 plus 10 plus 9 plus 11 plus 9 plus 7 divided by 6. Alright. I'm going to do that in my calculator. Alright, and so I got 8.3 repeating. 8 1/3. I'm just going to round that here to 8.333. Alright, so now the best thing to do is to make a chart. So first I'm going to list all of my x values in my chart. And I'm going to sort my x values. Now you don't have to sort the data values, but if you do and you work out something for one, then it's going to be the same for the next one. So you'd really just write down everything twice. So I'm going to sort these 4, 9, 9, actually 4, 7, 9, 9, 10, and 11. Alright, now I need to calculate the deviations. These are the deviations about the mean. Okay, and how do we find the deviations? That's going to be x sub I minus x bar. So we're going to figure out the difference between the data item and the mean, or each data item and the mean. Okay, so for 4, that's going to be 4 minus 8.333. Alright, and so if you work that out in your calculator, we're going to get a negative 4.333. Then we look at the data item 7. So the difference there, 7 minus 8.333, that's just going to be negative 1.333. Alright, then 9 minus 8.333 is going to be 0.667. And then we have another 9. So that's really the main reason that I sorted this. You can see if you have to do one calculation, you'll only have to do it the one time. Just write it down twice. Alright, the next one is 10 minus 8.333. And that's going to be 1.667. And then the last deviation about the mean will be 11 minus 8.333. So that's 2.667. Alright. So we have the deviation about the mean for each data item. Now, in our formula, if you remember, up here, we need the sum of those deviations squared. So, what I would suggest doing is make another column that is the squared deviations. Okay, I'll rewrite this back up here. Now, the squared deviations, that's going to be x sub I minus x bar squared. Sometimes when I'm doing these problems, if I'm working them out by hand, I won't write the words, I'll just write the symbols to tell me what I'm doing. Alright, and so now what we want to do is we want to take this negative 4.333 and square it. So once we do that, all of these values are guaranteed to be positive. Okay? So I can't do this in my head, so I'm going to have to type it in. Alright, so if I have that and I square it, I get 18 point. I'm going to round to 3 places again. I'm just going to stay consistent. I have 18.775. Alright, and I'm simply going to do that for each one of these data items. Alright. Almost done. Alright, so now, according to my formula, I want to take the sum of all of those. So I sum up the deviation squared. So this will be the sum, let's see, the sum of x sub I minus x bar squared is equal to, I just need to add these together. Alright, so I got 31.334. So that is my numerator, 31.334. So S squared, the variance, sample variance, is equal to 31.334 divided by n minus 1. So the number of data items minus 1. Alright, so I had 6 data items. So that's going to be divided by 6 minus 1, or 5. Alright, I got 6 point, if I rounded this to 3 decimal places, it would be 6.267. So what we did is we figured out the variance, which is the average squared deviation. And so this unit is actually, we a lot of times we won't say it, but it's like 6.267 square, and then I think this was minutes. Kind of like the unit that you would have for area or something like that, but that's not really that big of a deal. Now it's harder to understand how to use the variance without getting pretty complicated, getting in pretty deep, but it's easier to explain how to use the standard deviation, which is directly related to the variance. Okay? The standard deviation is simply the square root of the variance. Alright, the standard deviation is the square root of the variance. So the formula is the same. The only difference is that you take the square root. Okay, so if you were to look at these formulas on your formula sheet under Chapter 4, the formula sheet that comes with the book, then you'll see sample variance, population variance, then you see sample standard deviation and population standard deviation. So what your formula sheets have listed is that the standard deviation, like the sample standard deviation, would be just S, which is the square root of S squared. So if you find the variance and you take the square root of it, you get the sample standard deviation. Alright, and if you wanted to write down the formula, you'll notice it's the same formula it's just under a square root symbol. Alright, same for the population standard deviation. Alright, population standard deviation is just a lowercase sigma, and it's equal to the square root of the population variance. So it's the square root of the formula for population variance. Okay? So let's take this same problem out of the ebook and let's find the sample standard deviation. Alright, we have the sample variance here, S squared. So if I want, let's see, where are we? Right here. If I want the sample standard deviation, again, I simply take the sample variance and take the square root. I know that we did a lot of rounding. It's best not to round and actually carry out things further than we did. It just so happened that our mean was 8.3 repeating. So, you may want to carry things out 4 or 5 places, depending on what the directions ask. But if your final answer needs to be rounded to 3 places or 4 places, then that means you want to try to carry everything out to 5 or 6 places generally. That way it won't affect your answer at the end. I'm just going to put down what I got in the calculator after all of my rounding and stuff, so hopefully it won't do too much damage to this actual answer. But the answer is just the square root of that. So you can see if I rounded to, let's say, again, 3 places, that would be 2.503. So the sample standard deviation, 2.503. And we use the sample standard deviation actually a lot more than we do the variance in formulas. And I will eventually show you why.